You've probably heard the phrase a million times, right? The sixth mass extinction. It conjures up these images of, a catastrophe on the same level as the asteroid that wiped out the dinosaurs. And yeah, that's a terrifying thought. But is it actually scientifically true? Well, that's what we're going to dig into.
So, yeah, that's the big question, isn't it? Are we really living through it? For a long time, a lot of scientists have been saying, yes, absolutely. And look, when you see the number of species disappearing, it kind of feels like a slam dunk case. But a new study is throwing a bit of a wrench in the works, and the answer it gives is, well, it's a lot more complicated than you might think.
And this is what's at stake. Just look at it. Places like the New Caledonia Barrier Reef, these incredibly intricate, beautiful webs of life. So this whole debate, it isn't just some dusty academic argument. It's about the future of everything, every single one of these amazing ecosystems all over the planet.
So get this, a new study out of Tohoku University in Japan has a pretty surprising answer. Not yet. Yeah, you heard that right. They're arguing that if you stick to the strict, scientific definition, the sixth mass extinction hasn't actually started. But hold on before you go breathing a huge sigh of relief. Trust me, the full story is way, way more serious.
And here's the researcher himself, Kunio Kaiho, spelling it out. He says the current rate doesn't technically qualify yet. But, and this is a huge but, the trends show that it eventually will. We're not there, but we're heading straight for it. So, to really get what he's saying, we've got to break down what the term mass extinction even means in the first place.
Okay, so let's dive into the science here. Turns out, you can't just throw that term around. There's a very specific checklist for these kinds of planet-altering events. So it really boils down to two key things. First is the sheer scale of the loss, the magnitude. We're talking about losing a huge chunk of all life on the planet. And the second thing is speed. All that loss has to happen in what's considered a short amount of time, geologically speaking. And, for a geologist, short means less than 2.8 million years, which sounds crazy long to us, but on the timescale of the Earth, it's the blink of an eye.
Right. So how do scientists even know if the current rate is out of the ordinary? Well, they compare it to something called the background rate of extinction. Think of this as the normal, slow, steady heartbeat of the planet, where species just naturally disappear over vast stretches of time. It's like Earth's natural rhythm of life and death.
Okay, so what's the actual threshold? What's the tipping point for a major mass extinction? It's this. Scientists are looking for a loss of more than 60% of all species. Let that sink in. That's not just a few animals, that's more than half of everything. It is an unbelievably high bar to clear. And this is where it gets really, really scary. Because while we haven't lost 60% of species yet, scientists estimate that the speed we're losing them, the rate of extinction, is about 100 times faster than that normal, natural background rate. 100 times! We're losing life at a truly staggering speed. So, how does what's happening now stack up against the big ones from the past? Well, when you look at Earth's history of these cataclysms, you start to see some really important differences.
Yeah. Over the last 500 million years, our planet has gone through 5 of these massive wipeouts. We're talking everything from volcanic eruptions that choke the skies to, of course, the one everyone knows, the asteroid that slammed into Earth and said goodbye to the dinosaurs 66 million years ago. Life has been pushed right to the edge, over and over again.
And here is the absolute key difference. All those past extinctions, they were kicked off by these huge, sudden natural disasters. Asteroids, volcanoes, you name it. But this time, this crisis is completely different. It's us. We're the cause. And according to that new study, the really critical difference is the speed of the change.
Okay, this is really the core of the whole argument. Think about it. When a giant asteroid hits, the environment changes, boom, overnight. There's nowhere to go, no time to evolve or adapt, you're just done. What Kaiho is arguing is that the changes we're causing now, as terrible as they are happening more gradually. And that might give some species a tiny window of opportunity to move, to migrate, to survive. A chance they just didn't have during those instant cataclysms of the past. But, and this is super important, if we get too hung up on that strict technical definition, we could be missing the point. The bigger picture is way more urgent.
So the study zooms in on climate change specifically. And it says that for global warming by itself to trigger a mass extinction event, the temperature shift would have to be absolutely massive.
How massive?
We're talking a 9 degrees Celsius jump in the global average temperature. That's over 16 degrees Fahrenheit. I mean, that is just a colossal number. And to put that in perspective, even the absolute worst-case scenario climate models don't see that happening until at least the year 2500.
But, and here's the crucial catch, if we only focus on that mass extinction label and that far-off temperature number, we're taking our eyes off the ball. It can totally distract us from the very real threats that are happening right now, today.
And in fact, another expert, a guy named David Storch, makes a great point. He says that rising temperature isn't even the #1 villain right now. Not even close. The stuff we're doing directly to the land, to the oceans, that's having a way bigger, way more immediate effect.
And he's talking about these things. These are the real drivers of today's biodiversity crisis. We're talking about habitat loss from clear-cutting forests. We're talking about pollution. We're talking about overhunting and overfishing. And we're talking about invasive species. These are the things driving extinction right now, and it has nothing to do with that long-term temperature forecast. And then there's one last pretty chilling detail. Most of the numbers we have, most of our data, it focuses on the big stuff. Mammals, birds. We are almost completely in the dark about what's happening to the invertebrates. The insects, the corals, the snails, the little things that actually make up the vast, vast majority of animal life. Which means the real situation, it's probably much, much worse than we even know.
So this all brings us to the most important question, doesn't it? We can sit here and argue about the label, debate the scientific definition of whether this is officially a mass extinction or not. But the trend is crystal clear. The rate of loss is skyrocketing. We know where the cause, and we know exactly where this path leads. So maybe the real question isn't about the label we use. Maybe the real question is, what are we going to do about it?